promise, I'm here to talk to you about digital visualization and machine learning in 5 minutes, my experiences. Okay, so the first question you have to ask is, what is the problem we are trying to solve? You really need to understand the problem you're trying to solve in order to understand it. And then, for whom are we trying to solve this problem? And there are multiple whoms. When I go into a restaurant, I'm looking for good, healthy food. When my daughter goes into a restaurant, she's looking for desserts and ice cream and French fries. So the other thing you ask is why? Why do they care? Your customers don't care about you. Sorry to tell you, they don't care about your product, your service. They don't care about data visualization or machine learning. They care about themselves, their dreams, their goals. Now, they will care much more if you help them reach their goals. And to do that, you need to understand their goals as well as their needs and deepest desires. So understand the problem you're trying to solve, whom you're trying to solve for, multiple people, and why they care. Then you can start thinking about data visualization and machine learning. Now, data visualization is looking at data to understand the past and tell a story. So I worked on the COVID tracking project. COVID, it's a big thing in the news. You may have heard of it. So one of the things we did is we gave charts of data starting back when nobody knew what the heck was going on. And we gave nationwide charts. But, I don't care about the nation. I live in New Jersey. I want to see my chart. So I could get a chart of New Jersey and we give them a little drop down so they could see what was going on in the area. It's what I care about. Remember that, what I care about, right? So another great thing about visualizations is you want to facilitate appropriate comparisons. How do daily deaths and daily cases compare? Like one of the big things was, what's the difference? The more tests I do, the more cases. Well, what if I just plotted it? I could actually tell. Shocking. So facilitating appropriate comparisons. And you want to use data visualizations to tell a story. So Atlantic, which told a story on, what we know about race and ethnicity data and how it applies to COVID based on data, based on facts. What a concept, facts. Okay, machine learning, intelligence augmentation, intelligence automation, and artificial stupidity. All right, intelligence augmentation. So think about Usain Bolt. The fastest man can run 27.33 miles per hour. Neil Campbell, with a bicycle, has the Guinness World Record 174 miles per hour. So machine learning, when you use it to augment your intelligence, that's like using a bicycle. Machine learning is like a bicycle for the mind. So we use it in our augmented reality, sort of knowing what's going on, maybe seeing a person's faces that I recognize and saying, oh, I can't remember their name. It tells me their name and like when we last met, what their kids' names are, so I can actually act like I remember them and I care. Because caring and empathy is important, remember that. So there's also intelligence automation, where everything is completely automated. It's driving the car for me. Now ask yourself, why in an automated self-driving car is the interior of car exactly the same? Why don't we redesign that? By the way, this happens a lot in history. Think about that one, kids. Okay, now there is artificial stupidity. I'm going to skip this slide because I don't have time. So here's PayPal, a chat agent. Hey, I'm a chat agent. I'm still learning. Let me help you. And the person goes, I got scammed. The response of PayPal, great. That is artificial stupidity. Fine. All right, now here's some more interesting stuff. Boston housing data. And we're sort of looking at the actual versus predictions of housing prices and the amount of loan you'll get based on your housing price. And it looks like there's a pretty good correlation here. It seems like it's going pretty well. There's a nice straight line linear regression there. But if you look at the data, remember, look at the data, get to understand it, you'll notice some of the data talks about, are they black or not? What's the socioeconomic status of the population? Could there be bias in here? Just because we're using data does not mean we're removing bias. All right, so this is artificial stupidity, and we actually have math to, measure fairness proxies. Don't have time to go into that right now. So if we remove the data on whether they're black or not and what their socioeconomic status is, the fairness improves, but it's still unfair. Why? Because the data, even if you remove whether they're black or not, has proxies for bias in it. Data can be very biased. Be careful. So there are math ways we can sort of play with this and sort of remove some of the fairness. But when you do that, you sort of have to trade off fairness with accuracy. And here's another thing. In order to do this, I have to know their race. So here's an ethical question for you. Is knowing their race and about their socioeconomic status and giving up some of these privacy issues, about myself a fair trade-off to get more fair and unbiased artificial intelligence? Good question. Let me know what you find out in the future. So, good things to watch. Coded Bias, great things. Joy Bulamani from MIT Media Lab did a great thing where she was interested in facial recognition, and none of the algorithms from Google, Microsoft, Amazon could recognize her face until she put on a white mask. Kathy O'Neill wrote a great book on weapons of mass destruction. Watch the documentary, read the book. Tips for beginners. Altair, great for data visualization because it actually uses a grammar associated with visualization. Think about grammar and how it applies. Words matter. Some good tools: Anaconda, Google Colab, Pandas, great books. You kids may have heard of them. Python for data analysis, Wes McKinney, great book. And by the way, for you kids, you can actually run it in Google Colab. So you actually get to play with the book and run it. Because you want to play with the book because you don't learn to walk by following the rules. You never see a kid, let me see how to walk. Let me read the book and then I'll do it. No, you learn by doing and by falling over. Kids fall over a lot before they learn how to walk. Why? And failure is why science is so successful. So go out, do, fall, fail, and learn from failure. It's not fail fast, it's learn faster. Thank you.